Here is the question for multi-channel, that is Abel-Baker problem, and the question is consider simulation table for Abel and Baker problem where time between arrivals are given here with the probability and Baker is faster than Abel. In this problem the priority for Baker is greater than priority for Abel. In the previous videos we considered Abel priority is higher than the Baker, but here Baker priority is higher than the Abel. Keep it in mind, the Baker priority is higher than Abel. Okay, now the service time for Abel is given here with the probability and service time for Baker is given here with the probability, and random digit assignment for arrivals are given here and random digits for service time are given here. Just count the number of random digits for arrival and service time. Just note down 1 2 3 4 5 6 7 8 9. So these are 9. 1 2 3 4 5 6 7 8 9 10. Okay, these are 10. Now these values are not equal, so we know that first value should be always considered as 0. So putting 0, then the numbers will be 10. Okay, now moving to the solution. Here is the first step in solution, that is distribution of inter-arrival time, and customer numbers can be known from the question, and probability is also given in the question. Okay, for inter-arrival time. Okay, now cumulative probability. First probability value is equals to the cumulative probability value, so keep it as it is. Now second, just add these two values and you will get the answer, that is 0.20 plus 0.15. The value is 0.35, and now just add these two values and you will get this answer, that is 0.35 plus 0.05, that is 0.40. Now the value will be 0.60. Now value is 1.00. Now next, for the random digit assignment, keep the values at the right side which are after the decimal values, that is 20, 35, 40, 60, 00. Now we are making the intervals from 1 to 20, 21 to 35, 36 to 40, 41 to 60, 61 to 00. Now next, second step is distribution of service time. For Abel table is here, for Baker table is here. We need to calculate them separately because the values for probability and for Abel is given separately, and for probability value of Baker is given separately, so we are calculating them separately. Okay, next, cumulative probability can be calculated same how we are calculated in the step 1, that is just adding and all. Okay, then you will get the answer 0.20, 0.25, 0.40, 0.60, 100. Now making the intervals 21 to 25, 26 to 40, 41 to 60, 61 to 00. Now for the Baker also you just proceed the same. You will get the answer. Okay, next, moving to the third step, and the third step is to determine inter-arrival time. Here customer numbers and random digits are known, they are given in the question. The first value is considered as 0, so putting dash there, or you can put 0 also, and inter-arrival time is 0. Next, just take the value, that is 89, go to the first table and check where 89 lies. 89 lies in the here 89 lies in the 5th row, so the value is 5. Okay, just write the value 5 here. Now take 90 and go to the first table and check where 90 lies. It is also lying in the 5th row, so the value is 5 here. Now continue for the other values, and now the value of arrival time can be calculated as, just put the first value 0 and then add these two and you will get the answer, that is 5. So 5 plus 5, 10. So continue for the other values also. Okay. Now moving to the 4th step. Now the 4th step is to determine service time, and we know random digit for service time. Okay, that is given in the question. Just copy the values, and service time for able and service time for baker is calculated separately, so just calculate them separate. Okay, now take the value 49 and go to the second step and check where 89 lies for both able and baker. Okay, 49 here, 49 lies in the 6th row for able, and 49 lies in 6th row for a baker. So we are writing 6 for both the values, that is for able and baker. Okay, just follow for other values also, you will get the result. Okay, now moving to the 5th step, that is simulation table. Now the arrival time we know that, and service time for able and service time for baker is also we know that, we have calculated them. And first, the first customer arrives at time 0. Here the priority is higher for a baker, not for the able, so we will first go to the time service begin for the baker, and the first customer arriving at 0, so time service begin is 0, and service time for baker in the first customer is 6, so we are writing 6 here, and time service end will be 0 plus 6, so 6 here. And caller delay, which means customer waiting time, that is the customer does not wait, as he arrives the time service begun is also same at the 0 only, so we are writing 0 here. And time spent in a system can be calculated using the formula, that is service time plus waiting time, then it will be 6. And for idle time, for the first value, don't use the formula, just write the value of time service end. Okay, so 6, the value is 6. Now to the next customer, that is second customer. Second customer arrives at 5. Now he first priority is baker, so we will go to the baker only, check whether he is free. No, the baker is not free, so we are moving here to the able. Okay, now the time service begin is 5, then time service for the second customer in the able table is 6, so we are taking 6 here, that is from this for able. This for the second customer, the value is 6 for the service, so we are considering 6 here. Next, the time service end value will be, that is 5 plus 6 is 11. Okay, now putting dash here, then the caller delay is 0, and time spent in a system is service time plus WT, that is 6 plus there is no waiting time, so 6. And idle time, now use the formula, that is time service begin for the current customer, that is 5, then minus time service and for the previous customer, that is 6, then that will be minus 1. just neglect the sign and write the value here. So 1. Now for the third customer, the arriving time is 10. Then check whether the baker is free. Yes, he is free, so 10 here. And he does not wait, so caller delay is 0, and time spent in a system and idle time can be calculated using the formulas. And for the fourth customers, that is the arrival time is 14. Check whether they are busy. No, he is free, so 14 here and dash here. Now 19 because the baker is free, and now the baker is busy, so only we are moving to the able, so 21 here. Next, baker is still busy, so moving to the able, that is 23 here. And now the baker is free, so moving to the baker, so the value is 28 here. Then for the ninth customer, the arrival time is 30, and now the baker is not free, so moving to the able. And for the last customer, that is 35, the baker is free, so moving to the baker. So before watching this video, please watch the previous videos for better understanding, okay? And the notes are available in my blog. Please visit my blog. Thanks for watching.